Hello everyone and welcome to Advent of Code day 11. Today is a little bit later. I'm sorry for that. We had a couple of problems at home with power outages and so on, and therefore I couldn't make it to the standard time. So therefore now 3 hours later, I hope some of you will nonetheless enjoy it or have some interested of it. Okay, so let's start and looking at the today's puzzle. Monkey in the middle. As you finally start making your way upriver, you realize your pack is much lighter than you remember. Just then, one of the items from your pack goes flying overhead. Monkeys are playing keep away with your missing things. To get your stuff back, you need to be able to predict where the monkeys will throw your items. After some careful observation, you realize the monkeys operate based on how worried you are about each item. You take some notes on the items each monkey currently has. Now, how worried you are about those items and how the monkey makes decisions based on your worry level. For example, starting items 7998, operation, new equal old times 19, test divisible by 23. If true, throw to monkey 2. If false, throw to monkey 3. New equals old plus 6. What does this operation actually mean? I don't get it. Test divisible by old times old. Each monkey has several attributes. Starting items lists your worry level for each item the monkey is currently holding. In the order they will be inspected. So the worry, okay. Okay, so basically they test if they... But what is the operation? Operation shows how your worry level changes as that monkey inspects an item. Okay, an operation like new equals old times 5 means your worry level after the monkey inspected the item is 5 times whatever your worry level was before inspection. Okay, test shows how the monkey uses your worry level to decide where to throw an item. If true, shows what happens with an item if the test was true, and if false, shows okay. After each monkey inspects an item, but before it tests your worry level, your relief that the monkey's inspection didn't damage the item causes your worry level to be divided by 3 and rounded down to the nearest integer. The monkeys take turns inspecting and throwing items. On a single monkey's after each monkey inspects an item, but before it tests your worry level. Okay, what is then the inspection? The inspection is this test. And this is... Okay. Okay, your relief that the monkey's inspection didn't damage the item causes your worry level to be divided by 3 and rounded down to the nearest integer. So basically all those values will be after the test divided by 3 and then rounded down. The monkeys take turns inspecting and throwing items. On a single monkey's turn, it inspects and throws all of the items it is holding one at a time, and in the order listed. Monkey 0 goes first, then monkey 1, and so on, until each monkey had one turn. The process of each monkey taking a single turn is called a round. When a monkey throws an item to another monkey, the item goes on the end of the recipient monkey's list. The monkey that starts a round with no items could end up inspecting and throwing many items by the time its turn comes around. If a monkey is holding no items at the start of its turn ends. In the above example, the first round proceeds as follows. Okay. Monkey inspects an item with worry level of 79. Worry level is multiplied by 19. Why? I thought this should be done after each monkey, but before it tests your worry level. Ah, okay. Shows your error level that changes as the monkey inspects an item. So at that time, okay. Therefore, these happen before. Okay. This changes, so then it's divided by 3. And then comes the test. Okay, it's not divisible by 23. Okay. Understood. After round 1, the monkeys are holding items with these worry levels. Okay, these are probably things that we can use as debug output. We basically just try to replicate those printouts and see if they match basically what we calculate. Monkeys 2 and 3 aren't holding any items at the end of the round. They both inspected items during the round and threw them all before the round ended. This process continues for a few more rounds. After round 3, the monkeys are holding items with these worry levels. After round 4, after round 5, after round 6, 7, and so on and so on. After 15, the monkeys are holding items with these worries level 20 and so on. Chasing all of the monkeys at once is impossible. You're going to have to focus on the 2 most active monkeys if you want any hope of getting your stuff back. Count the total number of times each monkey inspects an item over 20 rounds. Okay, so the number, okay, how many, in this example, the 2 most monkeys, active monkeys inspected items 101 and 105 times. The level of monkey business in this situation can be found by multiplying these together. 10,605. Figure out which monkeys to chase down by counting how many items they inspect over 20 rounds. What is the level of monkey business after 20 rounds of stuff slinging simian shenanigans? Okay. So basically it's yeah, getting this. Oh, what is our input file? Our input file is probably something like that, right? You take some notes on the items. Ah, okay, this is, so basically we need to parse these things. Okay. Okay, I see. Good. So then let's start. Copy over this as our first input, and then create our new file, which will be test.txt, and add those lists. So actually this looks a little bit like YAML. I don't know, if you know YAML as a file, we can try to figure out if this is something that we can use for parsing this file. So it could become easier. New Go file. Let's start this day 11 dot, no, not gay, day 11.go. Yes, I want to edit. So, and for that, there is some way of oh no, I'm not sure if YAML is actually part of the standard library. Let's see, or let's check. Golang YAML. Okay, this is a separate package. Yeah, then. Because this is basically how YAML looks like here. You see this? So therefore it should be, it's always separated, so you have different indentations, and those are then keys and values are separated by this. Yeah, I think we will try it with YAML. Let's give it a try. Let's give it a try. So let's see, how do we use our Go YAML library. Go get. Okay, let's run that. There's a terminal. std11 go get, oh, okay, now we are downloading Go YAML. Okay, this means we could already use it. So is there some nice example? There's this struct. These are the different structs. Must be public in order for unmarshal to correctly populate the data. Okay. So let's think about how our type system should look like. So we have our type that is basically monkeys, just the monkeys, let's say it that way. So then we have a type monkey, and monkey is a struct again. And those structs have a couple of fields, so let's check them out. So the first field will be starting items, which will be a list YAML starting items. It will be in this way, right? It will be a slice of ints. So okay, then we have our operation, which will be just a string for the beginning, and our YAML will be operation. Then there is this test, and this again is a struct where we have if true, and this will then be if true, and this will be a string that is just YAML and if true, and we have the same for false. Okay, so and our monkeys are basically monkey 1, it's someone of type monkey with YAML monkey 0. Oh, okay, maybe then we rename them correspondingly monkey 0. So monkey 1, 2, 3, 3, 3, 2, 1. Okay. So we pass the starting items, we pass. Okay, let's see what comes out of it if we try now to use our YAML file. So how do we use that? Basically, we use this Go package in YAML. Okay. So import and then no, don't remove it, and then we can do something like YAML dot unmarshal. Okay. So, but for that we still need to load our file before. So therefore, start as usual, input file dot arrow, and read it from our file. That will be test.txt. Then, as usual, if arrow not equal nil, So if we have some error, we don't care, we just panic. And we try to close our input file. So now we need to read the whole file into, I don't know, is there some YAML unmarshal from file or something like that? Let's see. How do they unmarshal it? So they have just some bytes. Yeah, some data here, but how would we read it from file? Therefore, we would need to first read all in our file into a buffer. Okay. Colon, node file to buffer. No, not in a string variable, but IOUtil file. This sounds good. Ah, okay. Might be actually easier to use this then. Okay, let's give it a try. Read file. Learn something already. We are just in. So we don't use OS open, but we use this read file. Oh, it's deprecated. This is a pity. Deprecated. This function simply calls OS read. Ah, there's an OS read file. What the? OS read. What? Okay, nice. This is nice. So this no longer gives us our input file, but directly our input bytes or data. Let's say directly the input data, and the input data is then something that we can put directly into unmarshal, where we say our type that we want to read from the file is basically our monkeys. So therefore we create our monkey variables, monkeys, and this is a new monkey. Hey, keys. And then we read it into this monkey object. So if we get an error, we do the same as always. So if r equals nil, equals nil, we just panic. Okay. There's still something wrong. Let's do it that way and say monkeys. Okay. Good. We no longer have this input file, therefore we can directly close this. So, and now let's print basically our monkeys object after we read it in. So we can debug it as well. So therefore we can only check if what we read from YAML is basically what we were expecting to read. So monkeys at start x/n, and then we have our monkeys. So let's do the and go build day 11. Okay, mapping values are not allowed in this context. Okay, this doesn't sound correct. Let me see. YAML mapping values are not allowed in this context. YAML line 5. Ah, too bad. Too bad this is not valid YAML. The problem is, even if we can fix it now for our small toy example, the problem is still that we would need to fix it in the test input that we get, and this would be probably rather large file. So therefore I would prefer not to change it, so we have to get rid of our YAML idea, which is a pity. But okay, if this is it, then we will go back to line-wise parsing. Okay, I'm sorry. So this was a nice thing for a change, but it's nothing that we can rely on. So go back to how it was before and then start basically implementing the parser from our own. Again, since this is line-wise, we just create a new our new scanner, and then basically we scan through the file line by line. Okay. So now this means we have to parse individual monkeys. So we say, okay, parse monkey, and then we don't need these monkeys to have individual monkeys here, but we can basically just have a list. So get rid of this struct and say, hey, we have a list of monkey. Oh, slice, sorry, the slice. Empty slice declaration using a literal. Yeah, it is. Okay, let's say parse monkey from scanner. Okay, then we are doing it differently. Now we're implementing something like a pull parser, where basically the parser is pulling as long as it wants to parse something, so from the scanner. So this is where we don't do this and put in the line, but instead we just put the parser directly into this parse monkey, the scanner directly into this parse monkey function, and then the parse monkey function can directly return our new monkey. And then we have our monkeys and append to them. Append monkeys, our new monkey. So, since the monkeys they have state, right? So these things like the items that they are moving around, they are basically stateful, therefore we can remove them. No, we can't remove them, but we need to make sure that we always access them via pointer, so that we are basically generating that we can change them basically, and then they don't keep old state, or that their state is not correctly updated. Okay, so monkeys is, why is this append? Okay, so now let's implement this parse monkey and go back to our question, what is basically this pull parser? So we have here our scanner, which will be buff.io scanner. And the thing returns a monkey, or a pointer to a monkey. So this means basically we start when nothing has been scanned. So we first need to get the name. Or maybe we do it this way. So we first make scanner text line equals. So we need to know if we are between if we need to parse a monkey or something else. So therefore we can just check this here. Oh, there's a question. What is the difference between equals and colon equals? Yeah, this is basically something that is specific for Go. So if you are reusing some variable, then you need to use it without the colon. So a colon basically means create a new variable and assign it something for the start. So for example, here in monkeys, yeah, this is the first time we use this variable and we declare it to be of type here, or we initialize it with the value which will be a slice of pointers to monkey. So, and if we when we use it later on in a different assignment, we just use it without the colon because it's already there, right? So every time you see something like colon equals, this means that at this point you create a new variable. So this is basically the difference. Does this answer your question? Otherwise, if you need some further information, just ask. Okay, so now then let's continue. We have our line and we check if the line begins basically with monkey and something, and this will basically tell us, oh, okay, now we are reading a new monkey. So if line and then there was this strings, was it? Strings.index of monkey. And this basically tells us, okay, we are now, sorry, index of line monkey. So this tells us if that the line begins basically with monkey. So we are looking for this monkey blank within the line, and if it's included and it's the beginning of the line, then we know, okay, we are at one of those lines here. So, and therefore this means, okay, we are now there. Let's give over our scanner to basically the parse monkey method or function that can then create a monkey out of this and add it. So this means when we are now calling the parse monkey function, the first line that defines which monkey is basically defined is already done. So we can read our new line. Yeah, so we say scanner.tag, scanner.scan. Do we actually need this again? Or yeah, I think so. And then basically say, okay, line equals scanner dot text. So this should then give basically this line. So starting items 79 and 98. So, and then we can basically say, okay, our items, and then split them correctly. So we say parse starting items. And there we give over the line. Maybe we can just do it here. So if have here now the difference, so that we say that we check basically how does the line begin. Line now strings. Oh man, strings dot index of line, and then we check for starting items, and if this is equal 0, then we read the rest of the starting items. Else if strings starts with operation, then we do something like pass operation. These are things that we implement then later on. So what do we need? And the test, if it starts with test, then we, and then we expect if true and if false. Okay. For scanner dot scan. So we scan every time. So, and then we check basically what kind of line we have. This needs to be, I'm always mixing up Python and Go. This is something that will really take time. You think you will need the ID in field in Monkey? I don't think so that we need those explicitly at the moment. So I assume that basically, since we have the names are ID 0 to 3, I think that we can just map them directly to the position in the slice. So that the if the slice has 4 elements, then we index them by 0 to 3, and that this is good enough. But we will see. Maybe in the second part of the solution of today, or of the puzzle from today, there might be something that they get names or something like that. So then we might need to revisit that. But I think for now it's fine to just use the index numbers implicitly. But we will see. Maybe at some point it doesn't work out and we need to change our strategy for that. Okay, so back to our parsing the items, the items. So basically we have our line that defines the item. So then we need to remove basically everything here after that. So just how we basically take how len is this? So this is basically our command. So we do something like, so we want, what we need to get is basically the rest of this line, right? So therefore what we can easily do is just replace everything that is before and then make sure that we get the end. So therefore we say, where does our value start? Value position, or not items position. Let's call them items position. And this is basically, we can do this by the index from, and now we check what is the index of starting items. I totally missed something. The problem with our check here is basically that we assume that starting items is at the beginning. But if we look carefully to the file, I just realized that there are some blanks in before. So therefore, this doesn't necessarily work. So better just say, okay, our starting items need to be larger than 0, larger equals than 0. So, and then we check, okay, what is the position of starting items there? And we append item. So the position will be the position of the S, but we need to add basically the position, the length. So therefore plus len of. Yeah, this is not nice because we have here a lot of duplication and we will see that we will have the same problem with the other operations as well. So therefore we can think about implementing this in another way, so to be more flexible, but we will see. we can cross that bridge when we are there. So therefore we'll begin with line, and we check if the index of line. There are some problems with the stream right now. I'm sorry, terribly sorry for that. I have some problems with my Wi-Fi card, but this will hopefully be resolved by Tuesday when new hardware will arrive. So otherwise, you can check the YouTube versions of those solutions later, because they should be complete. So if there are some issues that parts of the solution will be missing from the video, or you have run into problems, make sure to check out the YouTube version later. So items position, yeah, okay. And then basically we know that afterwards there are the items, item string. And the item string is basically the line from the item's position till the end. So this automatically makes sure that we get the slice from this position till the end. So the sub slice, let's say it that way. Okay. Now with the item strings, we need to split them again, right? So we need to split them on those commata. So because there are different numbers of starting items that they have, and therefore we need to split them again. So we take our item string and we call strings.split, and this returns arbitrary number of strings that are basically split by this character that substring that I define here. So, and when we look at the input file, we see that those values are always separated by a comma and then a blank. So therefore we can just use this as a delimiter, and then we get our individual items as strings. So, and this is then the length of this slice basically is the number of numbers that we actually have here. So without the comma in between. And then, since we don't want to have them as strings, right? Because we need to use them. Those are the numbers that define the let's say the worrisome, or how was this called within the puzzle? The stress level. Can that be worry level? The worry level was it. So and this worry level changes, and we need to calculate with it. So therefore we need to have them as a number and not just as a string. So, and this is something that we can just map by creating a new map where we say, okay, we have our items, and the items is now a slice of int values. And those, they have the make, we create a new one, and the length is basically the same like the length of the items as string, right? Because we create for each string, we create a matching number. So, and then we just loop over our item as string, en item string is equal range from items as string, and then we can convert them with the items e is equal is this something that works? We will see. Arrow, and then we use by string conf dot a to I from item string. Okay, and as we see, this doesn't work. Unexpected end of statement. Yeah, okay. Unhandled error. If I handle the error, this is okay. So this seems to not work, so that we directly assign it to an existing variable. So therefore, item is then item.error is then equal this string conf. And then basically we assign items to item. Okay, and we need to check error again. If error, then again we just panic. We don't care at the moment. So this should allow us to basically pass all those individual starting items. So now basically when we look at the code, we see why it would have been easy to just use YAML, right? Because then we wouldn't need to implement all this boilerplate code that is just taking some information from there, formatting it in some different way and putting it somewhere else. So this would have been way easier. But okay, so now we need to assign those items, and for that basically we need our new monkey. Monkey, and then we can do something like monkey new monkey dot items, and this is basically our IR items that we passed there. Okay, so now let's go to the other parts. Operation. New equal old times 19. Okay, if we look at the operation, then we see that this is always new equals old something. New equals old plus 3. New equals old times old, and so on. So basically, this is something that we can quite easily pass, I would say. So therefore, we don't need an arbitrary parser that allows arbitrary operations. We can be really picky about what we support. Okay, but basically we start the same way. We say we have our line. This is then the, we need to find the position parameter, but the parameter now is fixed, right? Because the only thing that we need to check is basically from this here. So we can assume that this is always, okay, we do it anyhow. So operation, and we check operation, and then we say operation plus length operation. We want to know what comes after this new equals old stuff and blank. So basically the point what comes after it will be then just a symbol for an operator. So multiply or plus or plus, and then basically some other value, and the value could be also old. But this is basically what we can assume that this is currently that we can hard code this. So and this will be then the operation position, and this will be then our operation string. So, and we don't need to split it anywhere, but we can split it basically on blank. So to have the operator and the other value in separate. So operation parts. So, and then we have basically our operator will then be our operation parts 0, and our operation value will then be either the same So, or a fixed value. So operation value will then be, okay, how do we solve this? We take operation parts 1, and then depending on how the operation value is, we can store it differently. So how would we store it? So just storing it as a string is probably not the best way. So operator, and then we have our operation value, and the value could be some, let's say it's some pointer to some int, right? So we can use a pointer because this pointer would allow us to point also to other values. So what we could do is basically to point to the, but we don't have the old. So it can be either a fixed value or a pointer. Let's see it that way. We will see. Maybe we just say, okay, if it's nil, then we assume it's old. Something like that. Maybe this is easier. Okay, so we check if operation value equals old. Then, okay, we say monkey dot operation value is nil, else new monkey dot operation value, and this will be then the value that we pass from it. So basically we need to pass the number here, so the 3 or the 6 or the 19. And this is again something where we use our A to I, so our string conversion that we use often in other places as well. Operation value will be then here our value, and then we say you are the pointer to this value. Okay, and then we also need to store the operator. So new monkey dot operator is equal operator. Okay, so this now lets us pass the operation. Okay, as we see, it becomes more and more code and harder to see what it actually does. So we will see. Let's finish the test and then also those 2 lines, and then we will see how we can continue, and then maybe try to run it and see if what we are reading and what our monkey looks like after this this parsing step, if this is actually correct. So okay, so now our test. What is the test? Divisible by 23, by 19, by 13, by 17. So it's always about being divisible. Okay, this is fair enough. So we basically can assume that this is always the case with other people, with other monkeys as well, so that we don't find monkeys that have tests like greater than or something like that. That would be really hard then to extend this. So, and we do this the same way as before. So basically we are only interested in the number that comes after this divisible by. Therefore we parse it and try to find the correct position. So find the correct position for the test value position. And this will be then our test value string. And our test value string is then something that we basically need to convert with a to I. So test value string is this, and then we have our test value. So, and the test value is something that we need to store. So for our struct test, we need the value which is an int. So new monkey dot test dot value is equal test value. Okay, so therefore we should already have this part. So now let's look into the other conditions here. So if true, if false. So, and they are basically telling us just to which monkey to throw the things, and these are just numbers, so 0, 2, 1, 3, 0, 1. So we can just model them as pointers. So therefore we just don't see here throw to if true, throw to int if false. Okay. So this means we now read those values as separate strings. So we just copy this one and may implement now if true. If true, and then if true, throw to monkey. And this is then true, throw, true, throw, or throw if true. So throw if true, position, and this is then the throw if true string, and this is then throw if true. That's then our number, and we can just say throw to if true. Okay, so and this is for the true case, and now we can just copy it and make all trues to false. And then basically throw if false. Copy and paste code. Yeah, I know this doesn't look really nice, and there's a lot of repetition in here going on, but the first step is always to get something working, right? So make something that works, and then afterwards it's always a possibility to make it nice and better and more cleaned up. So but first have something that works. Okay, so this means basically we have our monkey that we have passed here, and then basically we just return our monkey. New monkey. Okay, but how do we break here? And we still need to know when basically we don't need to, we are at the end of our monkey and pass it, and this is basically here. Else if line equals empty line. So if we read empty line, then we can basically break. We know we have read far enough, so therefore we can return. So now we can add some additional check where we say, okay, here in this case we should only run into if we made some error, right? Because we are handling all of those individual lines, and if this line comes, then we jump out of it. So this is more as a fail-safe that can help us when we are debugging stuff, where we say, oh, we panic because basically we find some unexpected line. Unexpected line. So hopefully this doesn't happen. So now there's still one issue with the scanner. Cannot use scanner as type buff.io scanner. Why? Ah, okay. Why? Because it's a pointer, of course. So we just gave a pointer and not the object itself. So now let's see if we can pass multiple monkeys and how many monkeys we will have at the end. So just try to run it. Oh, run, go build 11. Okay, there's still something. Operation, unexpected line operation, new equals old times 19. Okay, so something is wrong with our operation. New equals old. The question is why? We are same error again, where we didn't check for the cases that we have some leading spaces in between. So this is still, yeah. Fixed it once, but this is the problem with copy-paste code, right? So you fix it in one place, but you see it in the others. Did you see operation of monkey 2, old times old? Yes, exactly. Yeah, this is basically, sorry for getting this only now. This is why we have this special case here. All right, this is the point why we check if this is old, and then we just set the value to nil and use nil as a marker that tells us, hey, no, we don't have a concrete value for that, but we will just need use what is old, what is the same value that was before. So this is currently, it's not really nice, but it could work as a workaround, and we have to be careful that we implement it this way as well, right? So if we now implement the code later that basically runs this operation, and they in this code we just check that we just try to use always the value, the numeric value, then this will break. Yeah, but this is actually something that makes it hard, or harder, let's say it that way. So as you see, there are a couple of things that are always a little bit different, than you could make it easier, right? But okay, we will see. So now our program ran successfully, and we now have here a list of monkeys. So, but as we see, these monkeys have just our these starting items. Maybe we should print these things a little bit more explicit. I don't understand exactly what we are seeing there, so therefore implement our toString method for our monkey string, which returns a string. And therefore what we do now is basically print out something that is more useful, let's say it that way. Format sprint, format.sprint sprintf. So where we say we have our items or monkey, and our items are %s. No, how can we, is there some nice way to print we will see. Items E, then basically we have our what is always the operator, operator will be %s and then %d. I'm not sure what this makes for nil. We will see how nil will be printed out. And then we tell our test, and the test looks like what is the value that it is divisible by. So %d, and then the monkey that it throws to if true, and then the monkey that it throws to if false. So, and now let's fill all those formatter wildcards. m.items, what is the first? The operator, m.operation value, then m.test.throw to the value, then okay, this is way too long. Let's break and then make it in separate lines, so this makes it easier to understand what are the individual fields. Otherwise this becomes really hard if the lines become too long. Okay, so and then return this as a string. Okay, run again, and we see, okay, now we are seeing it in a different way. This is basically yeah, okay. So this is, and this is now probably broken. Oh, what happens when we put in nil? Panic, yes, okay. We dereference a nil pointer. Arg. Yeah, of course. Now this is the problem with the old, right? So we still would like to print it out as a nice value. Are there some, do you know these things, ternary operators? Let's check something that makes it easy to return one value. Golang. Return one value depending on a condition. This would be really nice. Oh, what happens again here? Oh, internet. Why ICANN has no internet? Oh man, sorry for that. This is really, really annoying, and I hope that the package with the new Wi-Fi card will be there on Tuesday at least. So because this is not really workable. Aha, okay. In addition, full-blown. Yeah, okay. This is not really that helpful, but okay, fine for us. We take it anyway. So then, what we are doing, we just do it in front operation value, and we say it's nil at the beginning, and if m.operation value unequal nil, then basically we just refer it and print it. So we say operation value is equals to string conf dot I2R from the reference of m.operation value. So, and then we make this to a string instead, and this should then be easier to read. Okay, so basically what are we seeing here? So our monkey, and the input is 97 and 89. This is okay. Then the operation is multiply with the value 19. So for the others, for example, here this is +6. Here this is multiplication with nil, which will be our old. Yeah, okay. So these actually all look quite nice. This doesn't really look that nice. So a nicer way to print integer slices would be quite handy. I didn't. Sorry, I didn't correctly look at this and switched over. So basically, what we did now is move this code out. So there were we said, okay, depending on the operation value, we create just a string of it that is nil, or that is the number that we present there. So this makes it then easier, and then we get a far better output. It's still not 100% what it should be, but okay. So let's compare basically our monkeys. So let's compare the last monkey, for example. Okay, our last monkey says our items is 74. Check. Our operation value is old +3. This is check. If our test is divisible by 17, check, and if true, throw to monkey 0, check, and if false, throw to monkey 1, check as well. So let's check for the first one. Oh, maybe the second, the second before, which will be this one, the second last. So starting item 79, 79, check. Then 60, check. Then 97, check. Okay, then operator value will be, operation will be multiply. Yes, our value will be nil or old. Check. And the test is divisible by 13, check. And if true, throw to monkey 1. If false, throw to monkey 3. So therefore, I think it looks like that our code for parsing the monkey starting configuration from the file is not that wrong. This is quite nice, and I think we can be quite confident that this is something that we can work with. So now let's take a look again at the question what we actually need to implement, because this is currently just the foreplay, let's say it that way. So now we have to change the state of all those monkeys. The operation, the test. After each monkey inspects an item, but before it tests your worry level, your relief that the monkey's inspection didn't damage the item causes your worry level to be divided by 3 and rounded down to the nearest integer. The monkeys takes turn inspecting the throwing item. On a single monkey's round turn, it inspects and throws all the items it is holding one at a time, and in the order listed. Monkey 0 goes first, then monkey 1, and so on, until each monkey has had one turn. The process of each monkey taking a single turn is called a round. When a monkey throws an item to another monkey, the item goes to the end of the recipient's monkeys list. Okay, so now let's implement those things. So basically we need to run over those individual monkeys. Then basically inspect the items, item by item, right? Then change the worry level depending on depending on the operation, right? I think depending on the operation. And then they are done with inspecting this, so therefore the worry level is divided by 3. And then we do the check and see, okay, if now the worry level is whatever is defined for this monkey, then we either throw it to another monkey or to one of those other monkeys, and then we do it for the same. Okay, so basically these are two different loops, right? One loop where we do this, we have multiple loops, 3 loops actually. The first loop is basically about the individual rounds. So we have, how many rounds do we have? 20 rounds, I think. 20 rounds. And then within each round, we loop over all monkeys. And then within each monkey, we loop over all items that they have. So therefore, these are 3 nested loops that we now need to implement. So let's take a look and start with that. So monkey at start, this is basically fine. We check this. And now let's do this. So we have our round for round equals 1 plus round equals smaller 20. So I think 20 was the maximum round. And we do round plus plus. So now the next nested thing. So for monkey index, comma, monkey in range from monkeys. So, and now for the monkey, we loop basically over the individual items. For item index, comma, in item, in range monkey dot items. So, and now we need to implement the individual parts. So, first step, monkey worry level is multiplied by 19 to so basically now we need to operate on the worry level of the item. So the item itself has the worry level, right? So we need to change that. Okay, so so for this we need to know what different type of operation or operator we are using. For currently we can multiply, or basically we can also else if monkey, or we can append I don't know, add, sorry, not append, operator equals plus. Maybe there are other operators as well, so therefore we should check for that and then panic. So panic, because we will only implement those 2 at the moment. So therefore, if every time check for if what your expectation is actually holding true. Panic unknown format error function unknown operator monkey operator. Okay, so now basically we have our operator. So now how do we get the value? So if value equals 0, oh no, value equals item. So operation value. So basically we assign the operation value to be the same as the worry level, so as the item. So, and now we check if the operation value that is stored within the monkey, so operation value, if this is not equal nil. If this is not equal nil, this means basically that we have a value in there, and therefore we can overwrite the value with the correct value by just applying where this pointer is actually pointing at which value. So, and then based on the individual operator, we can just do things like here now monkey dot items, and then item index, and we basically update the item index, the value for it, because this is then, if we have the operator multiply, we do something like, does this actually work? This multiply equals, this is equal then operation value. And if we have add, we do the same thing, but just with plus. Yeah, and this should allow us to modify the individual values. So this is basically the first step. So vary level is multiplied by 19 in this case, or by the other monkey, vary level increases by 6 to 16, or by I don't know what the other monkeys are doing. So now comes the other part. Monkey gets bored with the item vary level is divided by 3 to 500, and this is something that always happens. So this is this. After each monkey inspects an item, but before it tests your vary level, your relief that the monkey's inspection didn't damage the item causes your vary level to be divided by 3 and rounded to the nearest integer. Okay, so let's do exactly that. So we take our item value. This is here. And we divide it by 3. And this is it. So this means we are already done with that part. So let's check what happens afterward. So now we do the test. We check, okay, what is the vary level right now? And and then basically depending on this vary level, we need to move this item and remove it. So this will now be a little bit problematic because we need to remove the item from the monkey while we are iterating over its list, right? So this is something that we need to be careful how we implement this. Current vary level is not divisible. Yeah, okay, let's see. So this is basically our test part. So if monkey dot test test value, and then we take our value here. So value, and we need to check if it's divisible by it, right? So, and this means basically we can check if there's some reminder after we divide or not. And this is basically this modulo operator. And if this is equals 0, we know that it's divisible by it. This means now we throw it to true to the true monkey, and here we throw it to the false monkey. Yeah, but now the question is, how do we actually throw them? And this is the tricky part, I think. We need to think about if we basically go back somehow, right? Because we remove an item from the slice, and therefore we need to change the index. We need to modify the loop that we are currently looping over. Yeah, okay, let's see how we can do that. Maybe there's something, I don't know. How does Golang handle range change slice while iteration? Change values while iterating in arrays. Iterate on my node. Yeah, okay, this is not the problem. Remove while ranging over it. This is basically the problem that we have, right? We want to remove some items from a slide while we range over it. As you mentioned earlier, you can allocate a new memory block and copy only valid elements to it. However, if you want to avoid the allocation, you can rewrite your slice in place. Okay, so if we copy to another index. Okay, so basically they are just copying it to previous version. Yeah, okay, but this doesn't solve the problem, does it? Maybe this is the easier or the safer method. As you mentioned, you can allocate new memory block and copy only valid elements to it. So basically this means we will always copy all those items and then create a new item list and then assign, after the loop is done, basically assign the new items. Let me think. But this means that we are always throwing them to the monkey. Are there some monkeys that throw the item to themselves? No, there aren't, right? So this means basically that they are always throwing those items away. Okay, yeah, then it becomes easier. We just copy it over and set a new empty slice as the monkey's items. And then basically just loop over them and append them to the monkey. Okay. Monkey new items equals make int 0. So we just create a new slice and old items equals monkey dot items, and then we basically set monkey items to items to this new item list, and we just iterate over our old items. This makes it way easier. Okay, so we don't have to care about it. And this basically means that we can... yeah, exactly. Sorry, I saw your comment only yet. You can remove all items after monkey is finished. After loop is done, items are empty. Yeah, you're 100% correct. This is something that I didn't saw at the beginning. And therefore, I would just do it before. If we do it before, then basically this means that if we have some monkey who is throwing it to themselves, then this should work as well, right? And therefore, we can just say, okay, we just create a new list. And then within here, basically, we just... try to append them to the list that the monkey currently has being set. So now, if it's true, basically, we have our true monkey, then we go to monkeys, take the index of true, if true, so basically monkey.test throw to if true, take the items and just append. And append our item that is basically now... what we need to change here is basically how we refer to this item, because this is no longer working. We need to make sure that we basically use item here overall. Use item. And then here use item as well. If monkey item, if item, and then we append to items the item. And this is equal append monkeys. Okay, this could work. This does not really look nice. Maybe we can just target monkey we move this out. Say here target monkey. Copy, copy. So, and then var target monkey int. So we create a new variable of type int. We assign there some values here. If false, this will be this monkey, and if true, this, and then we say target monkey will be target monkey items will be target monkey items appended plus the new item. I think this looks okay-ish. This doesn't, there's some error still, and there are some other problems. Okay, the item index is something that we don't need currently, it seems. And the monkey index is something that we currently don't need. So, any code that we are missing. So let's see. What have we in? We basically have our operator, our operation value that we get. We have our operator. Based on the operator and the operation value, basically we change the item. Then we reduce the worry level. Then we throw it to another monkey. And then we will see later. Yeah, thanks for looking to. I'm terribly sorry about the connection. This is something that I hope to be resolved by Tuesday. Have a good night, and yeah, if you are interested, you can see tomorrow how it was in you. I will upload the file to YouTube and the source code to GitLab, so therefore you can check the solution if you are interested in. Just take a look at the channel. There should be some links to GitLab and to YouTube as well. So, have a good night. Bye. So, let's continue. So, we have basically appended or thrown the item over to the other ones. Okay, so let's check again. What is the next step? Thrown to monkey, and so on. And then after the round 1, the monkeys are holding items with these worry levels. Okay, so then basically it's just printing out how the individual monkeys, what are their items. Okay, this is something that we can actually do quite easily. And then we run for 20 rounds and see what happens. And then afterwards we need to figure out what are the 2 most active monkeys. But this will be then when we know that our passing stuff around for the individual monkeys actually works. So therefore print after round . Okay, just print out which round we are currently running in, and then again looping over all monkeys so that we can print what they actually have for which items they actually have. So this was format printf monkey and then %s \n. So we have our monkey index, we have our monkey.items. Yeah, we definitely need to find a way that makes it easier to see what are in those items. So, and now we don't need this monkey index at the moment as well, so therefore just make it empty. So let's see what happens now. Cannot run. Oh no, we ran 20 rounds. Okay. I'm wondering why we don't see here monkey. Let's run again. Now we see everything. Okay, after 20 rounds, this is basically how it ends. So we have 10, 12, 14, 26, 34. We have 245, 93, 53, 199, 115. Okay. Oh, this looks actually completely like the result from the browser here. This is nice because this is a substantial amount of code that we currently are writing. So therefore, getting it correct at the beginning, test.result. No, we don't want to add the test result. So if we just compare it, 10, 12, 14, 26, 34. 245, 93, 53, 199, 115. Okay, cool. So this means the only thing that is missing is now figuring out which are the two most active monkeys. So chasing all the monkeys at once is impossible. You're going to have to focus on the two most active monkeys if you want any hope of getting your stuff back. Count the total number of times each monkey inspects items over 20 rounds. So this is basically quite easy, right? Because the only thing that we need to do is introduce a new counter for each monkey variable, where we say inspections, and this is an int. And then within our, let's do it before the test. And then basically before we actually do the inspection, here, this is basically the code where we do the inspection. We do something like monkey.inspections plus plus. Right? So this should be it. And now we need to print out how many inspections each monkey did. Inspections after 20 rounds. We don't need printf here, since this is nothing. And then basically we just print out inspections. Monkey inspections. Okay, let's run it and see what we get. And again, run again. Okay, 101 inspections, 95 inspections, 7 inspections, and 105 inspections. Let's check to the browser. Correct. These are the same numbers that are basically within the solution of the test. Okay, nice, nice, nice. So then this means we need to input. What do we need to input? We need to multiply those numbers. Okay, so we need to calculate the monkey business, and monkey business situation can be found by getting the two most active monkeys and multiply their numbers. The level of monkey business in the situation can be found. Yeah, okay. So let's calculate the monkey business, and then we can try what works with our own. So monkey business, format print monkey business percent the So, and then for that, we store our most two active monkeys. For we have our two most. So therefore, our most active. Most active is just basically the name, and we make it a slice of times two monkey. So make, and they are basically 0. They are 2. So we create a slice of size 2, and then we loop over all monkeys, and we see if they are more active than the most active monkey. So let's see if most active, no, if most active 0 not equal nil. And so if we have a most active monkey and most active 0 dot inspections is smaller than our current monkey inspections, then we basically change most active 1 equals most active 0, and we are now, our current monkey is now the most active one, equals monkey. So, and the same test is something that we do basically for the second one, but then we only replace the second one. So this should allow us to get the two most in the two most, let's say, the two most active monkeys. So then we can easily calculate the monkey business by, say, most active dot inspections times most active second dot inspections, and this should then be monkey business. Let's see, run it. Invalid memory or nil pointer reference. This is not nice, where if it's where why is most active 0? So there's something going on, fishy going on. This is a pity that now at the, so short before the end. So this is, of course, we need to update it if it's either nil or we have more. So if it's nil, we need to update this as well. So obviously this was wrong. Sorry. Okay, no, but we get a different number for monkey business. What? 11,025. Count the total number of times each monkey inspects items over 20 rounds. 100 times 100 times 105. So if we check again, why this monkey business should be 10,605 and not what we get out of it. Our monkey business is okay, 101 times 105. this should be 10,605. Why do we get 11,025? This doesn't make sense. Most active. Let's look into our most actives. 105, 105. What? Else we only need to do this once. Otherwise we are overwriting both monkeys with the same one. Aha. And now we have the same, the correct result. 10,605. Okay, now let's get our monkey business input. Whoa, these are 7 monkeys. Okay, 7 monkeys. This means there's more to do. I should have checked for that before. But okay, I think we shouldn't be in problems here. Input.txt. So now let's check if there's some other things. So this is using old, this is plus, times, plus, divisible by 2, by 5, by 4, divisible. Yeah, okay, so this should run out of the box without any changes to our code, because we range over multiple monkeys. So let's see what happens if we now use our other monkeys and run it. Okay, our monkey business. This is a printf. It's missing. So we have multiple monkeys with, we didn't print out the number of inspections with the monkey %d inspections, and then monkey index. So make this also clear. Monkey index. Which monkey had how many inspections? So, and we have 228 and we have 222 as monkey. So let's try to see if this is actually the correct result for our input. I hope it is actually. Yes, and it is. Okay, nice. Nice. Continue to part 2. You're worried you might not ever get your items back. So worried, in fact, that your relief that a monkey's inspection didn't damage an item no longer causes your worry level to be divided by 3. Unfortunately, that relief was all that was keeping your worry levels from reaching ridiculous levels. You will need to find another way to keep your worries levels manageable. At this rate, you might be putting up with these monkeys for a very long time, possibly 10,000 rounds. With these new rules, you can still figure out the monkey business after 10,000 rounds, using the same example as above. Okay, what is the change to the rule? You're worried you might not ever get your items back. So worried, in fact, that your relief that a monkey's inspection didn't damage an item no longer causes your worry level to be divided by 3. You will need to find another way to keep your worry level manageable. Yeah, but how? Multiplying these together, the level of monkeys. Okay. It might be that this gets to levels where you have the problem that basically you have numbers that, let's say, that get too large so that they wrap around, so that you end up with numbers that are too large to fit into the memory, or not into the memory, but into one value. And this is something that we can see. I think we should not have this problem since we use int, and int should be 64-bit at least, on my machine. It's a new type with the underlying type in. These types are different, so it might be. We will see. Otherwise, we can try to make it explicitly in 64. So let's try to make the rule, change the rule. So basically the only thing that we did here is this. So part 1 comment for part 2 and run it again. And we get, oh my god. These monkey item names are insane. What is our monkey business? Let's see what is our monkey business for the normal input, for the test input. Without that. 10,197. Ah, and we have 10,000 rounds. After 10,000 rounds, okay. So we also need to change the rounds. Rounds equal. Part 1. Part 2. Const rounds equal 10,000. And then here we have our rounds. We run it. Okay, maybe we should remove a little bit of those debug values. Remove this debug. So, and now it has, what is then the value? Okay, 2.6 billion something, which is different. And the items, the numbers are also different. So this means now, even if we are using int64, those numbers get insanely high. Okay, now we need to think. So we could try to run those. Is there something like big integer or something like that? So run big integer, something which an arbitrary with an arbitrary precision. That are not only 64-bit. Converting to and from other types. So we have our big, converting into big int is simple. It has to pass through int64 like so, and then afterwards, okay, there are some ways to convert it, okay, and but the important part is how do we calculate with them. Okay. Still here. Yeah, welcome. Did you remove the line? Yes, I did remove the line. Here. This is basically where I removed it. The problem is now that basically they are now, don't fit within the memory. So I'm thinking about if it was easier to just use big numbers, but I don't know. I'm not really sure if this is the correct solution at the moment. I'm wondering if we can just do it, since we are only adding and multiplying, if we could use some modulo stuff, but I'm not 100% if doing some modulo instead, running all those things within mod, I don't know, something. But for that I would need to understand what are then the operations. So basically our operations are always adding stuff, which is fine, and testing divisible. So divisible, since this test divisible is basically if I have something within a modular ring, so I could create a modular ring that contains all those. If this is all by the number that you get by multiplying all those things that we should be that these tests are in. So basically, if we have now a modular ring by 5 times 2 times 13 times 19 times 11 times 3 times 7 times 17, I'm wondering if this should be enough. So just always take the result and then mod this number. And let's do it just for the case and then see what will come out of it. So just use our monkeys and create from our monkeys that we read, basically, how do we call it? Modular ring? I don't know. Common mod base, I don't know. This is probably not the correct mathematical term for these things that I'm now doing, because I'm way above my pay grade in this direction, in this way. But this is one, and then basically we just do this for our monkeys and multiply it. So we say common mod base times equals monkey dot test dot value. So now we have our common mod base, and now what we should be able to do is basically normalize the item by running it mod item equals item mod common mod base. Maybe. So let's see what comes out of it. I think it could work. This number looks suspiciously similar to what we have within the browser. Let's see. 10,000 rounds. Yes, I think this looks really good. This looks really, really good. So in the browser was this number. Oh, not to the inputs. Okay, I don't care. So, okay, this basically in the browser seems to work. Or at least for our test input, this seems to have worked. So at least also those numbers here is basically corresponding to the numbers that we get here. So therefore, doesn't seem to be that wrong what I came up with. Nice. This is really surprising, actually. I wasn't expecting that this would be in any way work. It was just a guess or some feeling, let's say it that way. Intuition. So, but now let's see if in the end it also holds true for the correct, for the individual result that I should have. So we have this one, what is it? I don't know, a large number. 0, 4, 6, 3, 9, 11 billion. Okay. Let's copy and see if it actually works. Oh, no trailing. Woo! It worked. Nice, nice. This was a really nice surprise and a really good puzzle, I have to admit. So at least a puzzle where you need to come up with some things that are not just grunt work, basically writing out some trivial code and thinking about it. This was really nice. I really enjoyed it. Okay, so this will then close our stream for today. Was nice to have you all on board, and thanks for the hints and the good company. Yeah, then maybe we'll see tomorrow for day 12. Oh, it's already day 12 here, but okay, we will see. So have a nice evening, everyone. Good night, and till tomorrow. Bye.